This is Stephanie from statisticshowto.com. In this video, I'm going to show you what a z-score is. Let's say we have a normal distribution curve that's more familiarly known as the bell curve. I'm going to have some mean. Let's say I have a mean of 100. And then I'm going to have some observation. Let's say I have an observation of 125. What I want to know is how far away is my observation from the mean? What is the distance? Well, in statistics, z-scores are measured in standard deviations. And here's another bell curve with the standard deviations put in. If you're not familiar with standard deviations, you may want to click on the link in the description field. That will take you to a short article explaining what a standard deviation is on our website, statisticshowto.com. Right now, we're interested in standard deviations and how they relate to z-scores. A z-score of 0 tells you the observation is bang in the middle right here. This is the mean. A z-score of +1 will tell you a score is 1 standard deviation above the mean. And a z-score of +2 tells you you are 2 standard deviations above the mean. So that's what a positive z-score tells you. You're a certain number of standard deviations above the mean. And we can go back the other way too. The z-score of -1, it tells you you are -1 standard deviations below the mean. And -2, -3, and -4 z-scores will tell you how many standard deviations below the mean you are. So all the values to the left of the mean are negative, and all the values to the right of the mean are positive. The probability of any score occurring in this whole area is 100%. So this bell curve represents 100% of all scores. The probability of any observation happening in the top half of this bell curve is 50%. That's this side of the mean. And the probability of an observation appearing in this half of the curve is also 50%. The probability of a score happening between 0 and 1 standard deviations is 34%. And because our graph is symmetrical, that's also true for -1 standard deviations. So the probability of a score happening in this area right here between -1 and +1 standard deviations, or a z-score of -1 and +1, is 34 plus 34. That's 68%. The probability of an observation falling in this enlarged area between -2 and +2 standard deviations, well, that jumps to 97.72%. So let's go back to looking at the mean of 100. Let's say our observation for the right is here at 1.98 standard deviations away from the mean. That was our score of 125. A z-score at 1.98, if we look that up, is 0.4761. That's the area, and means that this value here from 0 to 1.98 is 47.61%, or 47.61% of all scores. And because we know this entire area here contains 50% of the scores, we're going to add our 50% and our 47.61% to get 97.61%. So if our mean is 100 and our z-score is 1.98, then 97.61% of all scores will fall below that number. I can also figure out the probability of an observation being greater than 125. That will be this tail area here. I know the entire area contains 100% of scores. And we also figured out the area below our observation of 125 contained 97.61% of scores. If I subtract those two, we get how much is in the tail. That gives me 2.39%. So this tail here contains 2.39% of all scores. In part 2 of this video, I will introduce you to the z-score formula, and I'll also show you how to calculate a z-score using that formula. This is Stephanie from statisticshowto.com. Thanks for checking in.